Hi, everyone. This is Sebastian Traeger, Managing Director, and welcome back to another episode of Reliability 4.0. As always, we're on a mission to make the world a more reliable place. And today we are joined by Juan Mendoza with Fresenius Medical. We are excited to have them. Juan, thank you so much for joining us to share your work and your insights with us.
Oh, thank you, Sebastian, for the invitation, and very happy to be here in your podcast.
So you were telling me you're in Knoxville. Tell us how you ended up coming to work at Fresenius and how you came to be in Knoxville.
Yes, I'm in this company for 3 years. Before this company was on San Luis, Missouri, and this was an opportunity for grow up professionally and as well the area. So I really like Knoxville. There is a lot of places for outdoor activities, and my family is happy as well here.
That's great. Well, I'm glad to hear that. Now, is that like a boxing belt above your shoulder?
Yes, there is a boxing belt, but it's not for boxing. We just received this recognition about 2 weeks ago for a company named Jiri. They create a software for automated electronic work instructions, and we
Okay.
receive it as the key customer for 2025.
Excellent. All right. Well, you looked like you could have been a boxer, so I just had to ask the question to see if that was in your background at all.
My son actually is practicing boxing for
Is that right?
almost 3 years. Yes.
Have you ever boxed against him?
No, at the beginning I might try, but at this point I will not try.
I've only boxed once in my life, and it was kind of on a whim. I was with some friends, and we had boxing gloves. We're like, oh, let's put them on and box. It is the most exhausting sport. Oh my goodness!
It
I was like,
is.
I could
It
not believe
is.
how exhausting that was to do that.
That's true.
So that's good. That's pretty neat that your son's doing this. Well, tell us a little bit about Fresenius and tell us about your role there.
Yes, Fresenius is a company that provides services and products for kidney disease, pretty much for the two main treatments, which is hemodialysis and peritoneal dialysis. In our case, we produce the consumables, which is a solution for peritoneal dialysis and a bicard for hemodialysis. And my role here is director for manufacturing engineering. So I'm in charge for everything related with maintenance and manufacturing engineering.
That's obviously a very big job being in charge of maintenance and manufacturing. So you're responsible to make sure all the product gets out and responsible for the team that does the operating and as well as the maintenance.
That is correct.
It's great. Well, that's good to hear. And you had recently done a talk on using rapid problem solving tools to diagnose equipment failures. What are some of the failures in your business that you see, and what would you say are the best practices for bringing rapid problem solving to bear?
Yes, pretty much everything related with equipment breakdowns or unplanned downtimes. So I learned this tool time ago, about 25 years ago, in a company in Mexico named Alcoa, and they based on Toyota production system. They call it A3, and they decide to use this tool for every breakdown or interruption of production over 15 minutes. That was very tight. In our case here in Fresenius, we established this as a 45 minutes threshold. So every any outage or interruption above 45 minutes, we have to do an RPS. And we have been implementing this since October 2024 and with really good results. So the team is engaged, and I highly recommend this tool for all the organization.
Can you give us an example of what, just kind of take us from problem discovery to kind of the process you put that through in order to solve a problem?
Yes, sure. Well, actually, there are five rules that we established for this methodology. The first thing is the containment action. So we have to make sure that the equipment is back again in production. That's the priority. So we cannot start doing an RPS while the equipment is still down. So we should focus first on the containment. So after the equipment is back in operation, the second rule is that we have to complete this RPS in no longer than 24 hours. Let's say that we had a leak in a pipe. We focus on fix the leak, but then before 24 hours, we have to start the RPS. And the other rule is that we have to do this in the Gemba. So we have to go to the floor where this happens, bring a team. That's the other rule. We have to have this in a team, and then we have to find the root cause for this issue. The reason to have this in the floor because there is all the evidence is there, and having a group of people we have different perspective. The other rule is that we have to finish the investigation in no longer than 5 days. Because if we don't complete this in 5 days, that's not rapid. That's why it is called a rapid problem solving. And then we have to implement all the actions and follow up. And the benefits of this is avoid the bugs coming up again. So if we just focus on the repair, there is high possibility that this will happen again.
Do you and so it sounds incredible, that process and kind of the standards that you guys set. How did you enforce those standards? What I assume people don't like to say, hey, I got to do these 5 steps. So how did you kind of bring about that culture change?
Yes, that's a good question. Thanks for asking. One important thing that is kind of a priority for the implementation is this needs to go from top to bottom. So we have to start first with the managers in order for them to believe and see the benefits of the tool. So that's how we started in October. I was the first who started in the process. So when this happened, I jumped as a facilitator for the RPSs and then cascade with the managers. So then the managers started doing the process through the time, and now they are cascading with the technician. It's not something kind of that quick, but needs to go top down. Otherwise, if you right away assign this to a technician, probably they will connect this with such quality, and they said, no, this is not for us. This is more a quality issues. But that's the best way to do this cascade from top to bottom.
So is that a process you brought with you from a different organization, or did you have someone, again, top down, say to you, this is what I want you to do?
Yes, I learned this, as I mentioned, about 25 years ago, and I have been using for all the organizations that I have been working here. Here in Fresenius, and it's not kind of the reinventing the wheel. This is a really old tool that all the companies use, but the methodology in regards of the implementation and the rules to execute it is kind of a key for having a successful outcome.
Okay, that's good. What metrics do you focus on then? So, when you talk about bringing this to bear and seeing results, what are those metrics that you're seeing to indicate that problems are getting solved, they're not recurring, and kind of making progress on what you're hoping to?
Yes, sure. Well, here in Fresenius, our main metric is OEE. We connect all the improvements to the OEE. That's where we want to see the results. And more specific, if we break the OEE for maintenance, is the unplanned downtime. So we have a threshold for unplanned downtime, and that's where we are seeing the improvement. And yes, of course, we saw the improvements through the time. In other organizations, here we are not doing this yet, but we will do in the near future. Mean time between failures is another metric. For example, in Alcoa, about 25 years ago, we used that metric. Here we are not using that yet, but that's the plan for the near future.
Excellent. So our company does a lot around root cause analysis, and you're talking about, not RCA, but RPS. How are these different or similar in your mind?
Well, the difference, RCA is part of the RPS. The difference, I will say, this is a quick investigation to apply solutions right away. It is not, I will say, 100% effective or efficient, but it gives you the opportunity to complete the actions quick. There are other problems that are more complex, such as chronic issues that happen every X time, or that's where we apply something more kind of a deep dive on the problem, which is more close to the RCAs. We use for that something called 8 disciplines, which is 8 steps. At the end, all are based on the PDCA.
Right.
And one of the steps is find the root cause analysis. But these RPS, the main value added is needs to be quick in the floor right away after the issue happened and implement the actions as fast as possible.
So are you effectively saying you're trading a little bit of maybe accuracy for speed.
That is correct. Yes, sometimes we spend too much time in a not complex issue and we pretend to make it perfect and we end up finding another issue. We forget the one that we was investigating and we didn't finish none of them.
So you would rather, yeah, how do you kind of walk someone through the logic of that? Because I think a lot of times, again, when we see people do RCAs, there does seem to be a over, sometimes like a little bit too much emphasis on it's got to be perfect. And I feel like sometimes that the perfect is the enemy of the good enough, because in that same time of making one perfect, you might have been able to do five, you know, five different investigations, which would have yielded better results than just putting it all into that one.
Yes, the difference that I can notice is the RPS is more focused on equipment breakdowns. A pump that was failed, a bearing that was seized, a leak that happened in the line. The RCA or the steps that we use here is more related with the process. So it's a defect that is happening with X frequency that is not easy to identify what is the cause of the defect of the problem. That is where we apply more a deep investigation.
So give an example of one of those, for example.
Yes, for the deep investigation, I can share one that happened time ago that was a difficult one. It was a defect in an aluminum chamber for an sterilizer that was cosmetic, but that equipment price was above $100,000. So no one to buy $100,000 with a spot inside of the chamber. And that happened after a process that was passivation. So before passivation, it was not noticeable, the defect. So we went to different, through all the process for the root cause analysis, make the key on the root cause analysis with the 8 steps is that we have to prove that the factor is directly related with the outcome. In this case, we define the factors and we have to prove kind of a scientific method, make an experiment or duplicate the issue. And if that factor is direct, that's how we connected with the problem. In this case, the problem was overheat. That chamber was welded with a robot and the aluminum welded is not stable. So it requires rework. The robot welding is a very stable parameter, but the rework was not. So the operator that does the rework kind of increased current on the process, and that created overheat. That it was noticeable until the chamber was on the finishing process. And actually, we did an investigation with a university with an electronic microscope when they see the difference on the structure, and they said this is caused by heat. So that's kind of an extreme example,
good.
But very
That's great going example. No, it's really appreciate that walking through it. It's very helpful. Well, we can kind of keep talking about so you would recommend to others out there effectively, hey, let's create two tracks, a track that is rapid, still as deep as you can go, but just time box it. Don't give yourself more than 5 days, do it right away, etc. If you put those parameters in place, that kind of is like the immediacy of that and the quickness of that offsets for any kind of deepness that you might be missing. But then there's also this category for, hey, there are some process or chronic problems that we do want to do a little more deep dive into.
Yes, that is correct. I would think that 80% of the issues could be solved through the basics, such as the RPS. The other 20, it requires more deepest investigations, such step or the mic, depends on the type of issue.
That's good. Well, one other thing I want to ask about before kind of we close, just around innovation. What are you seeing that's the most innovative in your work these days, whether AI or IoT, or what are you seeing out there?
Yes. Well, AI is on all the. We are using AI actually in condition monitoring with a company called Traction. So we installed sensors for vibration monitoring, and the way that they use AI is these devices are connected on their network, and they can compare the performance with other similar equipment that they have on the network, and based on that, they kind of fine-tuning the performance to detect an anomaly. So we just finished this pilot and we are in the process to implement it on the rest of the equipment. AI is kind of the today's better tool that everybody want to use.
Right. Well, and it's I think we're getting close to the point where is AI an innovation anymore? It's just so built into what we're doing, right? It's like, yeah, of course that's a thing, but it is still helpful to hear. Well, it's been great talking to you, Juan. I always like to ask people for kind of one final word, just based on your history, your work history, kind of put in your mind, you're speaking to either a younger engineer or somebody in the field. What would you want to share with them as a way to help focus them, or even talking to yourself as looking back on your career? What would you want to have said when you were younger?
Yes, well, something I will say is go back to the basics. We received a visit a few months ago from a consultant that gave us a concept that is called flap. He said that 80% of the issues is caused by flap, which is fastener, lubrication, alignment, and balance. So before you start putting sensor on the equipment, make sure that it is balanced, aligned, keep good lubrication. And after that, if everything is good, we can go for more advanced. I think that's a good tip.
Yeah, make sure you got the basics right, the fundamentals. And
Yes.
Once that's happening, think about adding on. And in some ways, that goes with your rapid approach to problem solving, right? Like, hey, if you're not doing the basics quickly,
Yes.
doesn't matter if you're doing more because you're going to miss some things. I think that's such a helpful insight. Well, Juan, thank you so much for being with us again. Juan's the Director of Manufacturing and Engineering at Fresenius. And so we are just so thankful to have you on the show. We appreciate you joining us.
Thanks, Sebastian.
And to all listeners out there, really anyone, we're about helping engineers solve problems. We want them to take more steps using technology where possible to solve problems. And we hope this conversation has been helpful in that. Again, if you're looking for anything related to RCA, whether training or resources and materials, check out reliability.com. And of course, if you're looking to implement RCA solutions quickly, check out our software, EasyRCA. That's all we have for today, folks. Thanks for joining us. And thank you for being on this journey with us as we seek to make the world a more reliable place. We'll see you on the next episode. Take care.